Hi guys, it's Miss H, and today we're going to be talking about solubility. In order to talk about solubility, we quickly need to go over what solutions were. So remember, we talked about this back in Unit 1. So a solution is a homogeneous mixture in which one substance is dissolved in another. Recall that a homogeneous mixture is one that has the same chemical composition all the way through and looks the same all the way through. It is a physical combination of two or more substances, so those parts are evenly blended. The substance that does the dissolving is called the solvent, and the substance that gets dissolved is called the solute. In labs that we are going to do, we're mostly going to be having our solvent be water, and our solutes are going to be things that you'd have around the house like salt or sugar. Also recall when we talked about solutions, we talked about like dissolves like. What that means is that substances can only dissolve similar substances or only be dissolved by similar substances. So polar solvents will dissolve ionic and polar solutes, and nonpolar solvents will dissolve nonpolar solutes. This is why we consider water to be the universal solvent, because most of the substances that we want to dissolve are either ionic compounds like salt or are polar compounds. When we're talking about dissolving, there's more than one way that a substance can dissolve. The first method of dissolving is called dissociation. In dissociation, ionic compounds break up into their individual ions. This is a physical change because it can be reversed. So our example that we see down here, we have our clump of sodium chloride or table salt gets broken down into its individual ions when dissolved in water. And so those actual individual ions break up, and you now have free-floating sodium ions and chloride ions. And this is why ionic compounds typically will carry an electrical charge, because of those individual ions floating around in there. The second method of dissolving is called dispersion. This is how covalent compounds break up. So in dispersion, you have a covalent compound that breaks into smaller and smaller pieces of itself. And so to make things a little bit simpler here, I just use a big capital S to represent sugar, and then it gets broken down into smaller little capital S's for the dissociation in water. Dispersion in water, not dissociation. Dissociation is ionic. This is dispersion. This is covalent. I highly recommend taking a look at the Tyler DeWitt video on methods of dissolving, because his visuals are a lot better than mine. The final method of dissolving is actually a little bit different, because it is not a physical change. It is actually a chemical change, and that is called ionization. Ionization is where you take a neutral compound and then give it a charge. What factors actually affect the rate of dissolving? So what can you do to change how quickly something dissolves, speed it up or slow it down? The first thing we can do is change the temperature. So you've probably tried making something like tea or Kool-Aid or something like that before, and you know that if you start with hot water, the Kool-Aid or the tea, the sugar, whatever it is, dissolves a lot faster. So as you increase the temperature, you increase the rate of dissolving. If you want to slow down how quickly something dissolves, you decrease the temperature. The second factor is agitation, or stirring, shaking, any of those sorts of things. If you take your sugar and you add it to your cup of tea and you don't do anything to it, it takes a while to dissolve. But if you stir it, it dissolves faster. Even if you don't stir it, eventually it will dissolve. It's just going to take a lot longer. So the more agitation, the more that you stir or shake, the faster it will dissolve. The final thing is the surface area. So as you increase the surface area, it dissolves faster. So let's take a look at something like sugar. If you have a sugar cube, that has a very low surface area because that sugar is very tightly packed together, and you can't get the internal pieces of sugar because of the external pieces of sugar blocking it. So it takes a long time to dissolve. As opposed to if you use regular table sugar, it takes a lot less time to dissolve because the water can attack all sides of each little individual sugar crystal. Once we take a look at all of these factors together and we start actually looking at what substances are dissolved, we want to start looking at, well, what do these numbers look like? So when we actually compare the amount of solute dissolved for a given temperature, we actually create what's called a solubility curve. And a solubility curve is a way for us to actually measure how much something is dissolved at a given temperature, or predict how much something is dissolved at a given temperature. What this comes down to is concentration. So concentration is how much solute there is dissolved in a given amount of solvent. The concentration can be one of three things. It can be unsaturated, meaning that it has less than the maximum amount of solute dissolved. This means that I could add more to it and it would still continue to dissolve. Saturated means that it has the maximum amount dissolved. So if I try to add any more to it, it will just sit at the bottom. It will not dissolve. It will just stay there. And then supersaturated is where you have more solute than you should be able to hold. We do this by doing things like we heat it up, we dissolve all the substance in it, like the sugar, and then we cool it back down. And as long as we don't put any sugar in there that's not dissolved, it will continue to stay in the solution. That's a supersaturated solution. So when we look at all of these on a curve, we're going to create what's called a solubility curve, and we want to actually look like what is this saturated, unsaturated, supersaturated look like on a solubility curve. So let's take a look at the NaCl here. Okay, this NaCl right here is what we're going to take a look at. So if I were to take a point like this one right here, if that point is on the line, if the point is on the line, then we say that the solution is saturated. So if the point is on the line, then the solution is saturated. Let's say that we looked at this point down here. Okay, if the point is under the line, then the solution is unsaturated. Under and unsaturated go together. If we were to look at something like this point up here, then that would be the point being above the line, which would mean that it is supersaturated. So when we are comparing these saturation levels, we always read it as the point is blank to the line. So if the point is on the line, the solution is saturated. So sodium chloride is saturated with 40 grams of sodium chloride in 100 grams of water at 90 degrees Celsius. If I have 30 grams at 60 degrees Celsius, I am unsaturated. If I have 40 grams at 50 degrees Celsius, I am supersaturated. But that's just looking at sodium chloride. I'm not looking at anything else on this graph at that time. I'm looking at just one specific substance and looking at how that point compares. So if I were to look at that 40 grams of solute at 90 degrees Celsius, if I were to be looking at something like the potassium chlorate instead, that would be unsaturated because that point is under the line for the potassium chlorate. For this guy right here. Okay, that point is under the line. Another thing we can look at with the solubility curve is what's the most affected. So that would be the steepest line. Most affected would be the steepest line. Okay, and the least affected would be the flattest line. So sodium chloride is the least affected by the change in temperature from 10 to 30 degrees Celsius because it's the flattest line there. The most affected from 10 to 30 degrees Celsius would be the one with the steepest line, which looks like it would probably be the potassium nitrate, the KNO3. The other thing we could look at is what is the amount of solute dissolved in the solvent. So I could say if I have lead nitrate at 20 degrees Celsius, how much would I need to have dissolved in order to create a saturated solution? That would be a problem that could be asked. You could also be asked things like which is the most soluble, so that would be the one that has the highest point. So if I looked at 10 degrees Celsius, what's the most soluble? The sodium nitrate, the NaNO3. What's the least soluble? It would be the lowest point. That would be the KClO3, the potassium chlorate. So that's the kind of questions that you'd see asked about a solubility curve.